Now that we've heard those definitions of the commutative property of addition and multiplication, let's try to come up with our own definition that makes more sense to us and how we really apply this property or these properties into real-world applications. Let's look at the commutative property of addition first. And let's just use a problem. Let's say 18 plus 16. Conventionally, we would just add from top to bottom and get our answer. 8 plus 6 would be 14. Carry our 1. And again, we would just add going down. 1 plus 1 plus 1 is 3, giving us 34. But the great thing about the commutative property of addition says that we can actually add going down or adding going back up because we're using the same numbers and they both come out the same answer. 6 plus 8 is 14. And again, 1 plus 1 plus 1 is still 3. Let's look at this not in a vertical form but also in a horizontal form. Let's say 7 plus 8. That equals 15. Let's turn that around and see if we come up with the same answer. 8 plus 7 also equals 15. So to me, this kind of helps you with mental math because as you were learning your addition facts in younger grades or earlier grades, you may have been stronger with your 8s than your 7s. And that's great because guess what? The commutative property lets you turn that 7 plus 8 around and use 8 plus 7 to get the same answer. And you feel more comfortable and more confident using it. Now let's look at the commutative property of multiplication and see if the same holds true here. And we'll just use, let's say, 14 times 12. Well, the commutative property of multiplication says that most of the time we start here with our 2 and multiply up to get 8. 2 times 4 would be 8. But actually you could also do 4 times 2 and get 8. Let's try to work this problem, solve this problem, by doing the standard way we usually do it. 2 times 4 is 8, and 2 times 1 is 2. We drop our 0. 1 times 4 is 4, and 1 times 1 is 1. Then, of course, we add again, which, as we get to that step, we will be able to see that we could also use the commutative property of addition. But let's look back up at our our multiplication up top. 2 times 4 is 8. We could also say 4 times 2 is 8. 2 times 1 is 2. But also 1 times 2 is 2. Commutative property. Easy? Simple to use? I think so. Again, moving down here to this part where we're going to do our addition. 8 plus 0 is the same as 0 plus 8. And that just turns out to be 8. Again, 2 plus 4, but if I wanted to use the commutative property, I could also say 4 plus 2, and I would get 6. Bring down our 1, and we have our answer of 168. So I think you can see where the commutative property of multiplication can come in handy sometimes to help us, again, with our mental math. Make it a little bit simpler, and make us feel a little bit more comfortable with those facts, whether they're addition or multiplication, and make us feel more comfortable in solving these problems. In conclusion, we've talked about the commutative property of addition and multiplication. The commutative property of addition states that when you have two add-ins, if you put them in different order, you still get the same result. And also in multiplication. When you change the order of the factors, you still get the same product. Let me leave you with a couple of questions. Have you ever used the commutative property in doing some math problems and maybe just didn't realize that you were using it? And also, why is there not a commutative property of subtraction and division? Could there be? Why or why not? Show what you know.